Hi everyone, it's me again. We're gonna dive deeper into networking devices. We'll be talking about bridges to start off with. A network bridge is a hardware device or a software that is used to join two separate computer networks to enable communication between them. Bridges can connect two local area networks or two network segments like subnets of a single LAN. A bridge allows a local area network to extend its footprint to cover a large physical area. Because bridges operate at the data link layer 2 of the OSI model, all networks or segments being connected must use the same data link layer protocols such as Ethernet. Many laptops computers have both wired and wireless network interface cards. These two adapters allow the laptop to establish simultaneous wired and wireless connections to two different networks. Most operating systems allow for a software network bridge to connect to the two networks. So bridges, a lot of people use bridges to make extensions to extend their network. I know that wasn't mentioned there, so just wanted to give you that additional information there too. Um, Note that a feature that Microsoft Windows known as Interconnection Sharing allows a single internet connection on a computer to be shared with other computers on the same local area network. However, a software network bridge cannot link ICS connections. Creating a software network bridge can create a security vulnerability. A bridge that links, for example, a secure wired local area network with an unsecured wireless network could create an unprotected link between the two, thus permitting access to the secured wired network from the unsecured wireless network. Note that enterprises can configure a wired Ethernet connection to automatically shut it off its detection features that the device connecting to it is using software network bridging. Switches. I hope some of you dealt with switches. If you don't know about switches, early local area networks used hubs, which is a standard network device for connecting multiple network devices so that they can function as a single network segment. Because hubs worked at the physical layer 1 of the OSI model, they did not read any of the data passing through them and thus were ignorant of the source and destination of the frames. A hub would receive only incoming frames, regenerate the electrical signal, and then send all the frames received out to all other devices connected to the hub. Each device would then decide if the frame was intended for it and retain it, or if it was for another device and then ignore it. In essence, a hub was a multi-port repeater. Whatever it received, it then passed on. Because a hub repeated all frames to all the attached network devices, it significantly and unnecessarily increased network traffic. But hubs were also a security risk. A threat actor could install software or a hardware device that captured and decoded packets on a client connected to the hub and view all network traffic. This would enable the threat actor to read and capture sensitive communications. So, anyone who's just tuning in right now and not understanding what we're talking about information security, IT support, basically, IT security. We're talking about network devices particularly. And we're talking about vulnerabilities that some of these network devices can have if not properly configured, and just how to implement them in your network infrastructure. As I said, anyone just tuning in, I'm a network engineer with a cybersecurity specialization. That's what I'm getting my education in, and if you have any questions about that, just please feel free to contact me anytime. I'm always available. So continuing talking about network devices, I just want you to note because of these hubs, we're talking about hubs right now, because of their impact on network traffic, the inherent security vulnerability, hubs are rarely used today. People don't like to use hubs. So if you're still using hubs, just understand there's security vulnerabilities. So they are rarely used today. So take them out of your network, basically. Your network infrastructure. Like a hub, a network switch is a device that connects network hosts. However, unlike a hub, a switch has a degree of intelligence. Operating at the data link layer, a switch can learn which device is connected to each of its ports. A switch learns by examining the media access control addresses of frames that it receives and then associates its ports with the MAC addresses of the device connected to that port, storing that information in a MAC address table. It can then forward only frames intended for one specific device or send frames to all devices, which is unicast or broadcast. And if you don't know what unicast and broadcasting is, just contact me. This not only improves network performance but also provides better security. A threat actor who installs software to capture packets on the computer attached to a switch will see only frames that are directed to that device and not those intended for any other network device. It is important for switches to be properly configured to provide a high degree of security. Proper configuration includes loop prevention and providing a flood guard. Loop prevention, basically, computer alpha, which is connected to switch A, wants to send. To talk more about loop prevention and flood guard, I think I'm going to make a separate video on that. I probably won't make a video and talking about that give you some graphical senses about that. Just not listening to it. Some things that loop prevention can help you mitigate is broadcast storms, which uses the IEEE 802.1d standard spanning tree algorithm. The STA, the spanning tree algorithm, the acronym for it is STA, can determine that a switch has multiple ways to communicate with the host and then to determine the best path of communication while blocking out other paths. So that is one of the reasons that you want to be able to configure that loop prevention in your inside on your switch to help your network. Note that although STA determines the best path, it also registers the other paths if the primary path is unavailable. Talking a bit more about flood guard, like I said, I'll talk about it, but demonstrating it, I'll probably use Cisco Packet Tracer, and I will virtualize some switches and some routers and some computers, and I'll bring up some terminals, and I'll be able to show you more about configurations and things like that. Flood guard, a MAC address table in a switch contains the MAC to port associations that the switch has learned. A threat agent may attempt a MAC flooding attack by overflowing the switch with Ethernet frames that have been spoofed so that each frame contains a different source MAC address, each appearing to come from a different computer. This can quickly consume all the memory called the content addressable memory, or CAM, for the MAC address table. Once the MAC address table is full and is unable to store any additional MAC addresses, the switch enters a fail open mode and functions like a network hub, broadcasting frames to all its ports. A threat actor could then install software or a hardware device that captures and decodes packets on one client connected to the switch and view all its traffic. The defense against MAC flooding attacks is a flood guard. Several vendors of switches have implemented a flood guard technology known as port security. Switches that support port security can be configured to limit the number of MAC addresses that can be learned on ports, restricting the number of incoming MAC addresses for a port prevents overwhelming the MAC address table. If additional MAC addresses are sent to a switch, the port security feature can be configured to ignore the new MAC addresses while allowing normal traffic from the single pre-approved MAC address. Basically put in restricted mode. Record a new MAC address up to the specific limit, sticky mode, or block the port entirely, which is shutdown mode. And basically, I know that's confusing. Like, without actually seeing those configurations, that hearing about that, just let me reading that and let inform me like that, it's hard to understand that. But I can do demonstrations on that later. Um, but I'm gonna cut this video right here. Um, I hope you enjoyed it. I hope you enjoyed the information that I'm sharing with you. And if, like I said, if you do have any problems, please do contact me. Like, share, comment, donate, and thank you for viewing my videos, and have a wonderful day. Bye.